Precalculus Lesson 18 begins with a strategy for solving exponential equations. This is from section 4.3 in the college algebra textbook. We look at our strategy here. First of all, we will rewrite the original equation in the form b to the m equals a to the n, or b to the m equals y if possible. If that's not possible, we will need to use a different strategy. Note that in the exponential equations we've solved so far, they've already been in one of these two forms. But let's go on for the case where we can get our original equation into the form b to the m equals a to the n. We look at those two bases, b and a. If b is equal to a, then we can use the one-to-one property of exponential functions to set our exponents, or m equal to n in this case. And then if b is not equal to a, we would proceed by taking the logarithm of both sides, usually the natural log, but there are some times when it makes more sense to use the logarithm of a different base. Now, for the case where b to the m equals y, we go ahead and also take the logarithm of both sides, again, usually the natural log. Once we have completed step 2 or step 3, we move on to solving the new equivalent equation. And you'll see in this lesson that our equations get a little bit more complicated than they've been up to this point. So let's go on and solve 2 times 4 raised to the power of 5x minus 2 equals 8 times 16 raised to the power of x. To start with, I'm going to divide through by 2 so that I have 4 raised to the power of 5x minus 2 equals 4 times 16 raised to the power of x, and then noting that 16 raised to the power of x is equal to 4 squared raised to the power of x, or 4 raised to the 2x. I'll go ahead and put 4 to the 2x in for 16 to the x on the right side of the equation. So we have 4 raised to the 5x minus 2 equals 4 raised to the power of 1 times 4 raised to the power of 2x. And now on the right side, we can rewrite 4 to the 1 times 4 raised to the 2x as 4 raised to the power of 1 plus 2x. Okay, and now if you see we have our equation in the form b to the m equals a to the n, and in this case our bases are the same. B is equal to a here, and so we can simply write 5x minus 2 equals 1 plus 2x. I will proceed by subtracting 2x from each side and adding 2 to get 3x equals 3, then divide through by 3 to end up with a solution of x equals 1. Now, for 10 raised to the 1 minus x equals 6 raised to the power of x, note that we have this equation already in the form b to the m equals a to the n. There's no way to simplify it further, and we can also see that 10 is not equal to 6, so we will need to proceed by taking the logarithm of both sides. In this case, seeing that I have a base 10 here, I'm going to use log to the base 10 and take log to the base 10 of each side of the equation. So I have log to the base 10 of 10 raised to the power of 1 minus x equals log to the base 10 of 6 raised to the x. Log to the base 10 of 10 raised to the power 1 minus x is equal to 1 minus x. So I have 1 minus x equals, and then on the right side of the equation, I can pull this x out in front of log 6. So now let's get all terms involving x to one side. It looks like the right side would work better here. So I'm going to add x to each side. I have 1 equals x log 6 plus x. And then on the right side, I will factor out an x. So I have x times log 6 plus 1. Then simply dividing through by log 6 plus 1 leaves me with x equals 1 over log 6 plus 1. And we have a solution. Okay, the next equation we're solving is 9 minus 2e raised to the power of 0.1x equals 1. Okay, so I will begin here, and you can kind of look ahead. I only have one base raised to an exponent here, and so I'm headed for the equation b to the m equals y. I want to get my equation into this format. The first thing I'll do here is subtract 8 from each side to give negative 2 times e raised to the 0.1x equals negative 8, then divide through by negative 2 to get e raised to the 0.1x equals 4. And now I have my equation in the form I've been aiming to get it into, and we can now take the natural log of each side. On the left side, the natural log of e raised to the 0.1x. On the right side, the natural log of 4. On the left side, the natural log of e raised to the 0.1x is the same as 0.1x. So we have 0.1x equals the natural log of 4. I divide through by 0.1 to get x equals the natural log of 4 over 0.1. 0.1 is the same as 1/10, so I have the natural log of 4 divided by 1/10. Dividing by 1/10 is the same as multiplying by 10 over 1, so the final solution here is x equals 10 times the natural log of 4. All right, now we have 50 over 1 plus e raised to the negative x equals 4. Seeing I have e raised to a power only once in here, again, I'm trying to get my equation into the form b to the m equals y. Okay, let's start here by multiplying both sides of the equation by the denominator of 1 plus e to the negative x. So that gives me 50 equals 4 times 1 plus e raised to the negative x, or 50 equals 4 plus 4 times e to the negative x. I'll subtract 4 from each side to get 46 equals 4 e to the negative x, and then divide through by 4. 46 divided by 4 is the same as 23 divided by 2. So we have 23 halves equals e to the negative x, and at this point I have my equation in the desired form, so we'll take the natural log of each side. The natural log of 23 halves equals the natural log of e raised to the negative x. So simplifying, this is the natural log of 23 halves equals equals just negative x. The natural log of e to the negative x is simply negative x. All I need to do now is multiply both sides of the equation by negative 1 and end up with a solution of x equals negative natural log of 23 halves. And we have it. Now let's solve the equation e raised to the 2x minus 3e to the x minus 10 equals 0. Well, this equation does not hit the format that we're used to. There's no way to get there, and so we need a different technique. This equation is quadratic in form. We've worked with quadratic in form equations before, and what I want to do to solve this equation is first rewrite it as e to the 2x is the same as e to the x squared. So we have e to the x squared minus 3e to the x minus 10 equals 0. I will do a u substitution. I'm going to let u equal e to the x, and that gives us u squared minus 3u minus 10 equals 0. We can factor into u minus 5 times u plus 2 and set each factor equal to 0, which will result in u equals 5 or u equals negative 2. Now remember, we're solving for e to the x, so I will substitute e to the x back in for u. Then we have e to the x equals 5 or e to the x equals negative 2. Okay, so for e to the x equals 5, this is in the form b to the m equals y. So I can take the natural log of each side here. The natural log of e to the x equals the natural log of 5. And the natural log of e to the x is equal to x, so we have the solution x equals natural log of 5. For e to the x equals -2, think of the graph of e to the x. It's always above the x-axis. E to the x is always positive. There's no way e to the x is ever going to be equal to -2. So this equation does not offer us an additional solution. We have the single solution x equals natural log of 5. Try on your own number 1. Solve the equation. 4 times 2 raised to the 3x equals 1/4 raised to the x minus 5.